Hello, learners. Once again, welcome back to this series of calculus primer videos. What we're going to be exploring in today's video is two things under the same umbrella. So we're going to be working with trigonometry, which I've found is kind of a calculus student's Achilles heel. So that's why I'm making these videos. And we're going to look at two separate things, but kind of related. The Pythagorean identity, which you can see right here, sine squared plus cosine squared equals 1. And we are also going to be looking at verifying identities. So basically taking these, all 6 trig functions, the sine, cosine, tangent, secant, cosecant, and cotangent, and being able to manipulate them in ways on one side of an equation to make it look like the other side of an equation. So without further ado, let's kind of break this down. Sine squared theta plus cosine squared theta is equal to 1. This is commonly referred to as the Pythagorean identity. And the reason why is because it does follow from Pythagorean's theorem, which is a squared plus b squared is equal to c squared. And if you kind of remember back to our video on the unit circle, if this is a right triangle in the first quadrant with angle theta, we know that the radius is 1, so that's the hypotenuse, so that c squared becomes a 1 squared. And this horizontal distance down here is represented by the cosine of theta, that is the horizontal projection. And the vertical projection is sine theta. And therefore, that's kind of our, our base is cosine squared, our height is sine squared. So since this is a right triangle, it follows that sine squared theta plus cosine squared theta is equal to 1 squared. And since 1 squared is 1, that's how we get that. So that's the derivation. And now what I want to do is derive 2 other identities from this. And I'm going to do this twice, and in both ways, I will change up my methods. So the first thing I'm going to do is I'm going to take each term and divide through by sine squared theta. Okay. And what we can do here is we notice that sine squared over sine squared, that'll give us 1. Cosine squared over sine squared, well, I know that if I look at my kind of cheat sheet over here, cosine over sine is cotangent. So cosine squared over sine squared is going to be cotangent squared. And 1 over sine squared, well, what's 1 over sine? Sorry. 1 over sine squared is going to be cosecant squared theta. All right, and so this is another identity. And what I'm going to do is I'm going to copy this, or rather cut it, and move it down here, or maybe not, because it kind of ruined my other stuff. Never mind. So that's, another identity that you've probably seen before. And if you haven't, well, here it is. And let's just change color. Let's do a blue. And now instead of dividing by sine squared, we're going to divide by cosine squared. All right. And what we'll notice is that sine squared over cosine squared, hopefully you do recognize this as tangent squared theta. Cosine squared over itself is 1. 1 over cosine squared is secant squared theta. Okay. So there you have another identity. Now, the thing with these identities, you have 1 plus cotangent squared is equal to cosecant squared. You can move the 1 in the cotangent squared, it's not going to change. So there's that. So now you have 3 really nice identities, and you may be kind of suffering from maybe some stress or post-trauma from your pre-calculus class or your algebra 2 class where you learned this, because there's so many identities. The nice thing about AP Calculus specifically is that these are really the only ones you need to know, okay? Now, a Calculus 1 course or Calculus 2 course in college, you'd probably need to know the extensive list of identities, but for AP Calculus AB and AP Calculus BC, this is sufficient, what's on this page right here, okay? Now, what we're gonna move on to is verifying identities. So you've probably seen problems like this, and this is, I like to think of it as an introduction to proofs, maybe a little bit higher level proofs for some math students, because basically what these problems are saying is prove that this identity is true, right? And so the way I'm gonna tackle this is by leaving one side of the equation alone and manipulating the other side of the equation. In this problem, I see that sine of x times secant of x is equal to tangent of x. So they're not asking us to solve, they're just asking us to verify that this is true. And the way I do this is I take anything that's not a sine or a cosine and I change it into sines and cosines. So I have the sine of x times the secant of x, and I know that secant of x and cosine of x are reciprocal functions. And then I have the sine of x times 1 over cosine of x, and I can write this nicely as sine of x over cosine of x. And I do know that this reduces to tangent of x. This was on this side, so therefore it's verified, we're done. Your teacher should be happy. Now let's move on. So I have 1 over sine of x, cotangent x is equal to 1 over cos, okay? Now don't freak out just because now you're seeing a quotient and all this stuff. We're gonna leave our signs the way they are. Any signs the way they are, the cosines the way they are, anything else, we're gonna move away, okay? So the first thing I am gonna do actually is break this into two quotients, the product of two quotients, and I have 1 over sine of x times 1 over the cotangent of x. And cotangent and tangent are reciprocal functions. So I could write it out like this. And then tangent needs to be rewritten as sine of x over the cosine of x. And then you should notice that these two terms will cancel out the product. And I'm left with 1 over the cosine of x. And that's what I had here, so it's verified. Now, if you did want to manipulate the right-hand side of the equation, 1 over cosine x is equal to secant x. And, you know, we get that there. So we're good to go. All right, now we're going to verify these equations. And what you'll notice is now I have, you know, a secant squared, I have a cosecant squared, tangent squared, all this stuff. So no sines and cosines. However, what you should know is, you know, from the Pythagorean identities that we went over previous to this, we're going to change anything on the left-hand side to its Pythagorean identity equivalent, right? So just for reference, we know that secant squared x, right? Let's look back up. Secant squared x is actually equal to tangent squared plus 1. So what I could do is replace this with a tangent squared x plus 1. And then we put that minus there. Cosecant squared, if we look back up, is equal to 1 plus cotangent squared, right? So I can replace that with 1 plus cotangent squared of x. I'm going to allow the computer to catch up to me. Okay, so we're good. All right. So now if I distribute this negative, then I notice that these, you know, plus 1 minus 1, they will cancel out. And I'm left with tangent squared x minus cotangent squared x. And that is what I had to begin with. So I'm good to go. All right, and I think finally, yep, finally, our final problem, I'm gonna basically do the same thing. So cosecant squared x is 1 plus cotangent squared x. And then I have cosine squared of x. Okay. I also know that, what can I do? I think I might have to get a little creative here. I could distribute. Let's follow that one, okay? So let's do cosine squared of x plus cotangent squared of x, cosine squared of x, okay? Let's just see where this takes us. It may not take us to where we want to be, but we can do some manipulation. Cotangent squared x is cosine squared of x over sine squared of x times cosine squared of x. And then we would get cosine to the fourth okay. And to be very transparent, I'm not exactly sure where I would go from here unless, so let's look at what I want, cosecant. So I know I'm gonna have a 1 over sine squared, all right? Maybe, nope, let's try something different. So this is okay, totally fine, all right? I could, let's look at this a little different. I notice I have something on the left-hand side that is the same as on the right-hand side, and that's that cosecant squared x. So in fact, let's try to just divide. This might actually look a little bit nicer, because that cancels out, and I'm left with cosine squared x here. The cosine squared over the cosine squared will give us 1, and then I'll have 1 minus 1 over cosecant squared x. Now I know that cosecant squared x is sine squared x because they are reciprocal functions. And once you know it, if I add the sine squared x to the other side, I am actually left with the Pythagorean identity, okay? So the nice thing in calculus is you're never going to be asked to verify a trigonometric identity, okay? Now, you will have to be able to use trigonometric identities, but the days of verifying and solving and all that stuff are kind of in the past, at least for AP Calculus. All right, so I hope you learned something. Leave a comment below if you have any questions, or my students, you can find me on Canvas. Thanks for tuning in. Happy learning.